Good morning. I am Shashi Kumar. Today we are going to have a session on Chandrayan. We have grown up listening to stories and songs about the moon from our childhood. According to Indian mythology and culture, moon holds a unique position in measuring time through the lunar calendar. It is a metaphor for beauty and a tool to make the children curious. Let us know more about the moon briefly through this video.
Changing world. But while the moon has remained largely unchanged during human history, our own understanding of it has evolved dramatically. Thanks to new observations, we now have not only unprecedented views of its surface, but a whole new tour of the moon that shows how both it and other rocky planets in our solar system have been shaped over billions of years. We'll start with one of the largest impacts, Oriental Basin. Over 150 moons orbit the solar system's planets, and one of those moons calls Earth home. The moon was formed about 4.5 billion years ago, when, according to one theory, the Earth slammed into another early planet. Debris from this collision began to orbit Earth and accumulated, forming today's moon. The moon is the fifth largest natural satellite in the solar system, with a diameter just under the width of China. It's composed of an iron-rich core, plus a mantle and crust containing minerals made of magnesium, oxygen, and silicon. The moon's surface was once geologically active and covered in an ocean of magma. But today, apart from traces of water ice, the surface is completely covered in dust and rocky debris. Countless craters dot the moon's surface, each formed by objects such as meteoroids, comets, and asteroids crashing onto the moon. The largest crater, the South Pole Aitken Basin, spans across a quarter of the moon's surface and is nearly deep enough to fit Mount Everest inside. The moon orbits our planet at an average distance of 30 Earths. It rotates at the same rate that it revolves. So as it revolves around our planet, the same side of the moon faces the Earth at all times. From the Earth's surface, we can observe 8 distinct traditionally recognized stages of the moon's illumination. Called lunar phases, they have been observed for thousands of years and even provided the basis for the earliest calendars. For most of human history, the moon could only be studied from afar. But on July 20th, 1969, humans were able to close that distance with the American spaceflight mission Apollo 11. That's one small step for man, one giant leap for mankind. It placed humans on the moon for the very first time, bringing our understanding of Earth's only natural satellite one step closer.
Moon is the Earth's natural satellite and one of the largest natural satellites in our solar system. Here are the some of the physical characteristics of the moon. Most of the lunar formation theories suggest the giant impact as the most probable beginning of the process that led to the current Earth-Moon configuration. Here is an animation for the same. The mass of the moon is equivalent to 12% of that of Earth's and has large specific angular momentum. Also, moon's roche radius, which is the distance it needs to be farther away from the Earth to not fall into the Earth's gravitational pull, and this integrate is pretty harmonious to maintain the current expansion of the lunar orbit by tidal interaction. Moreover, accretion is prevented within the distance too. Furthermore, Earth and Moon have essentially identical oxygen isotope compositions. Therefore, all these factors, along with the iron depletion, point out toward the giant canonical impact of a differentiated Mars sized object as being the strongest competitor among lunar evolution theories. The Moon is at an average distance of 384,399 km from the Earth. The minimum distance or the perigee is 3,62,600 km and the maximum distance or the apogee is 4,05,400 km. At an average speed of around 1.022 km per second, Moon takes about 29.5 days to complete one revolution around the Earth. The Moon rotates at an equatorial rotational speed of about 4.627 meter per second around its axis, tilted at about 6.687 degree to its orbital plane.
In 1959, the Soviet spacecraft Luna 3 beamed back images of something Earthlings had never before seen, the far side of the Moon. We always see the same old side of the Moon because the Moon rotates exactly once on its axis each time it orbits Earth. If it weren't spinning at all, we'd get at least one 360-degree view of its surface with each lap. If it were spinning twice as fast, we'd also see the Moon's entire surface more than once per orbit. But instead, our Moon's motions, like the spin and orbit of most other moons in our solar system, are remarkably in perfect sync. This wasn't always the case. Our best guess is that our own moon formed due to a massive asteroid impact, and its initial spin and dizzying 10-hour orbit were almost certainly not in sync with each other, though we don't know which was faster. At such close range, Earth's gravity deformed the moon into a slight oval, with one of its bulges facing Earth. Those bulges quickly swung out of alignment thanks to the moon's asynchronous spin and orbit, but Earth's gravity continually squeezed them back again. What's more, this gravitational tugging would have influenced the moon's rotation rate. If it was spinning more than once per orbit, Earth would pull at a slight angle against the moon's direction of rotation, slowing its spin. If the moon was spinning less than once per orbit, Earth would have pulled the other way, speeding its rotation. Whatever the case, it took just 1,000 years for the Earth's pull to adjust the moon's spin enough that one rotation of the moon corresponded to one trip around the Earth, leaving one side forever locked facing away. We do end up seeing some of that far side because the moon's elliptical orbit gives us peaks beyond its average eastern and western horizons, and its tilted axis causes moon seasons, revealing more of the lunar north or south poles. But those glimpses only add up to an extra 9%, leaving 41% of the moon hidden from Earth. Satellites, starting with Luna 3, have allowed us to map the rest, but it's safe to say that our relationship with the moon is still pretty one-sided.
The gravitational field strength of the Moon is 1.6 newtons per kilogram. It is very less compared to Earth's gravitational field strength due to the mass of the Moon being less. That is why astronauts cannot walk properly on Moon. Instead, they jump for each step. Our moon does not have a global dipolar magnetic field like planets. Instead, it has a crustal external magnetic field of the moon somewhere below zero point 0.2 nanoteslas, 100,000 lesser than the Earth's. This is because its core has crystallized about a billion years. Since then, only impacts and plasma clouds have contributed to the moon's magnetic field. The moon does not have an atmosphere that can be compared to planetary atmospheres because it has fewer molecules, leading them not to circulate and not absorb the radiations. However, some gases in small quantities and densities were detected around the moon, and the said atmosphere of the moon primarily consists of gases like neon, hydrogen, and helium. Small amounts of methane, carbon dioxide, ammonia, and argon. The pressure of zero point 0.3 nanopascals exists on the moon surface and depends on day and night. The geology of the moon is very different from that of the earth as there is no considerable atmosphere. Weather induced soil erosion that happens on earth does not take place on the moon. The moon's topography and bathymetric features are based more on its impact and volcanism. As there is not much noticeable tectonic activity, The knowledge of the moon's geology has been achieved by various missions, including the satellites, rovers, and even humans landing on the moon and getting back some material to the studied. The moon's dust is something that impacts have formed from asteroids and meteoroids, and the dust grain layer thus formed on the moon is called regolith. This is a layer of glassy particles formed by minerals in impact rocks. The composition of the moon's surface dust in the areas that have been explored usually consists of a majority of silica, followed by alumina, lime, and then a range of the metallic oxides. The moon has mainly two distinct categories of topography dividing its landscape. The areas which craters and other low-lying regions are called the Maria. Along with the lowlands and the hilly regions, areas are called the highlands. Highlands are anorthosite in nature and with a majority of feldspar in its composition. On the other hand, Maria is more basaltic with quickly cooled magnesium and iron containing lava. Apart from the Maria and the highlands, there are rilles formed as a result of lava channels. Wrinkle ridges resulted from the compressive tectonic forces. Domes that are the volcano heads covered with frozen lava. Impact craters and grabens are formed by the extensional stress. Water does not exist in liquid state on the surface of the moon due to the exposure to solar radiation along with the negligible low atmospheric pressure. However, several studies using probes and spacecrafts were done to find traces of uh, ice or any other form of water being present or left from the past. Finally, Chandrayan 1 in 2008 confirmed the existence of water by conducting spectroscopic using its moon meteorological mapper. Other observations and experiments like L Cross, Sophia, Chandrayaan 2, etc., have also studied this further. Here is a video to show how water was mapped on the lunar south pole by LRO.
Since the 1960s, scientists have suspected that frozen water could survive in permanently shadowed craters at the moon's poles. Both hydrogen and oxygen could be trapped within the lunar soil. So to find water on the moon, scientists are looking for indications of hydrogen using the Lunar Reconnaissance Orbiter's LEND neutron detector. By observing the interaction of neutrons with the lunar soil, scientists can interpret how much hydrogen is likely to be present. In order to make a detailed interpretation, however, LEND needs to observe a large number of neutrons. Because LRO is constantly moving, LEND is never over one place long enough to count many neutrons. So, to make a detailed interpretation of neutron flux, scientists add together many measurements from many orbits. With each orbit, LEND's dataset gets larger, and its picture of neutron flux continually improves over time. The dark blue regions in this visualization are places on the south pole of the moon with a suppressed flux of neutrons because of their interaction with hydrogen. These areas strongly suggest the presence of water frozen within the soil. While previous lunar missions have observed indications of hydrogen at the moon's south pole, the LEND measurements for the first time pinpoint where hydrogen, and thus water, is likely to exist. By combining years of LEND data, scientists see accumulating evidence that there is water on the moon. And as LRO continues to return data, our picture of the moon and its water will continue to get better in the years ahead.
We now know the several exploratory probes and rovers that were made and are sent to the moon. However, the first such spacecraft that reached the moon was the Luna 2, sent by the Soviet Space Agency in January 1959, followed by Luna 3 later the same year. After a few unsuccessful attempts, it was Ranger 7 in 1964 that finally brought NASA into the lunar mission race, followed by Ranger 8 in 1965 and Ranger 9 later that year. This was followed by successful mission by both NASA and Soviet, like Zond, Cosmos, Surveyor, Explorer, Soyuz, with flybys, impactors, orbiters, and landers in the 1960s. After these, in December 1968, NASA's Apollo 8 became the first mission to the moon, where three astronauts entered the lunar orbit and returned safely back to the Earth, followed by Apollo 10 in early 1969, and then finally Apollo 11 on 16 July 1969 became the first mission to land on the moon, as Neil Armstrong became the first person ever to set foot on the moon, followed by Buzz Aldrin with Michael Collins in the orbiter. Apollo 12 in late 1969, Apollo 14 in early 1971, Apollo 15 in mid 1971, Apollo 16 in early 1972, and Apollo 17 in late 72 were the only other missions with human crew landing on the moon. After this, no humans ever set foot on the moon again yet. However, several other missions, like further installments of Luna, Explorer, etc., along with the newer missions like Mariner, Geotel, Wind, Smart, Artemis, Stereo, Selen, WMAP, Nozomi, Changi, were sent throughout the following decades. In this phase, when Soviet Luna 17 became the first mission to land a rover successfully, Luno Code 1, on the moon, after which it sent a few other rovers like in Luna 21, etc. This was followed by NASA's Apollo missions rover that had sample collectors that the human crew brought back themselves. In 2008, ISRO joined the moon exploration with Chandrayan 1 and became the first lunar orbiter to officially confirm the traces of water on the moon, followed by Chandrayan 2 in 2019. In 2013, China launched its rover in the Chang'e 3 mission, followed by Chang'e 4 in 2018, which became the first spacecraft to soft land on the far side of the moon, while several other missions like L-Cross, Ebb, Ladi, TESS, Kukio, etc. went on to the moon in the 2000 and 2010s. China Chang'e 5 in November 2020 is the last spacecraft till date sent to the moon. As an exercise, you can explore about these missions. Various space agencies are planning many future missions for landing spacecraft and even for human crews to orbit and land on the moon through Artemis programs. Dear Moon project is by SpaceX to take space tourists around the moon. Chandrayaan 1 mission of ISRO is to provide a platform to explore the moon, our natural satellite, mainly to understand the surface topography and mineralogy of the moon. The term Chandrayaan comes from the Sanskrit, which means mooncraft. There are two Chandrayaan missions realized so far. Chandrayaan 1 mission is a lunar orbiter and carried an impactor, whereas Chandrayaan 2 had an orbiter, lander, and rover. ISRO plans to launch the Chandrayaan 3 mission in the latter part of 2022.
More than 1,000 scientists, more than 1 billion people, one aspiration: to witness India's giant leap to the moon. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. first time the scientists have launched with all so many complex technologies they have used, and they succeeded. That is historical according to me.
After travel of nearly 400,000 kilometers to achieve such a precision, perhaps it's a sort of a world record. And the anxiety before the event and the type of happiness what we have enjoyed after the event was tremendous.
All our hard work had paid dividends in that day. And once we say that we could receive the first signal from Chandrayan on day, on dot, at the set time from our facility was something wonderful for me.
We have collected large amount of imageries from the moon, and the information that has been brought in, it takes easily more than 10 years to have even a quick look at it.
We have already established the right type of credentials through the Chandrayaan and the other type of mission that today the international community is certainly looking forward to collaborating with India in major the undertakings in the context of space exploration.
India's first lunar mission Chandrayaan 1 was conceptualized after several discussions among Indian scientists from various backgrounds like engineering, communication, physics, chemistry, planetary sciences, astrophysics, and astronomy. This group of experts were formally called the National Lunar Task Force. The recommendation of this task force paved the way for India's first lunar mission. Chandrayaan 1 mission was launched on 22nd October 2008 by the PSLV C-11 rocket. ISRO succeeded in placing the Chandrayaan 1 in the lunar orbit in its maiden attempt, which many world-leading space agencies failed to achieve. ISRO made an astonishing discovery on the lunar surface with its impactor moon impact probe, launched with the orbiter, which found water on the moon. India is the first country to discover water on the moon, adding another feather to ISRO's fame. Chandrayaan 1 carried 11 different scientific instruments, popularly called payload, with a wide variety of research interests. Out of these 11 experiments, 5 were indigenously and the rest 6 devices were from the various other space agencies worldwide. The designed mission lifetime of Chandrayaan 1 was 2 years. Chandrayaan 1 mission was designed for high resolution chemical and mineralogical mapping and high resolution stereographic mapping of the lunar surface. Along with those mapping instruments, ISRO wanted to attempt to put an end to the most debated topic related to the presence of water on the moon. To accomplish these goals, ISRO developed the following instruments on board the orbiter: terrain mapping camera, hyperspectral imager, lunar laser ranging instrument, high energy gamma X-ray spectrometer, moon impact probe, Chandrayaan 1 X-ray fluorescence spectrometer, sub keV atom reflecting analyzer, miniature synthetic aperture radar, moon meteorological mapper, minisar, RADOM 7, that is the radiation dose monitor experiment, These are the instruments from space agencies around the world like NASA, JPL, and ESA. Moon Impact Probe was painted with India's tricolor national flag on all four sides when MIP hit the lunar surface on 14 November 2008. India became the fourth nation to have its national flag on the moon. After launching into a transfer orbit, a satellite or spaceship needs to follow a planned trajectory. For that, necessary rocket firings are made a few minutes at a time to achieve the required trajectory. Similarly, Chandrayaan 1 was injected into the moon's orbit through a series of orbital firings instead of direct Earth to moon orbit trajectory. This technique uses minimum fuel for achieving the lunar orbit and it uses relatively smaller size thruster engine. After launching from Sriharikota on October 22, 2008, Chandrayaan 1 was inserted in an elliptical geostationary transfer orbit with an apogee of 22,860 km and perigee of 255 km. Due to the extreme conditions at lunar orbit, the Chandrayaan 1 mission lasted only for 9 months. Though Chandrayaan 1 was functional only for around half of its expected lifetime, it contributed to several remarkable discoveries and provided valuable data for future lunar landing missions. The onboard cameras helped to create a three-dimensional map of the lunar surface and detected signatures of aluminum, silicon, and iron elements on the moon. Lunar poles and Apollo landing sites were studied for the future Indian lunar landing missions. USA's Moon Biological Mapper instrument made by NASA was onboard Chandrayaan 1 with the capability to detect the water presence on the lunar surface and lunar atmosphere. M3 was successfully in its objective and found hydroxyl ions on the lunar surface. It also found the water coming from beneath the surface of a crater on the moon. 3 months before the USA finding, ISRO has seen signatures of water on the moon during the MIP test at the moon's south pole. Following M3 results, ISRO published the test results of the MIP, making Chandrayaan 1 the first observatory to confirm the presence of water on the moon. The images from Chandrayaan 1 helped identifying the tectonic movements based on the cracks developed on the lunar surface. Chandrayaan 1 discovered an inactive lunar cave at the equator that supports human settlements on the moon. The discovery of potential lunar caves capable of protection from radiation, lunar dust, solar flares, and the foreign objects' impact on the lunar surface. Chandrayaan 1 discovery of widespread lunar surface hydration brought about a paradigm shift in our understanding of the volatile inventory of the moon. However, there remained an ambiguity as to the detection being hydroxyl radical or water molecule, with the main goal of resolving the ambiguity and demonstrating landing on the moon. The follow-up mission Chandrayaan 2 to the moon was envisaged. Unlike Chandrayaan 1, with the only orbiter, Chandrayaan 2 carried a lander and a rover along with orbiter. Chandrayaan 2's orbiter, lander Vikram or rover Pragyan were carried on board India's most powerful rocket GSLV Mark III and was launched on 22nd July 2019 from Satish Dhawan Space Center, Sriharikota. Orbiter payloads includes experiments to study high resolution topographic mapping, determination and three-dimensional mapping of water, hydroxyl, mineral and elemental composition on the lunar surface, the study of lunar exosphere and ionosphere and observing the X-rays emitted from the sun and its corona. Scientific instruments used to carry out mission objectives are the Terrain Mapping Camera 2, Chandrayaan 2 Large Area Soft X-ray Spectrometer, solar X-ray monitor, orbiter high-resolution camera, dual-frequency L and S-band synthetic aperture radar, imaging IR spectrometer, Chandrayaan 2 atmospheric compositional explorer 2, radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, dual frequency radio science experiment. All the scientific instruments were developed by ISAC, PRL, SAC, SPL, sub branches of ISRO. Hindustan Aeronautics Limited manufactured the orbiter's structure and delivered it to ISAC, which was integrated with all the equipment. Vikram lander's prime objective was to land the rover safely on the moon's south pole. To assist in safe landing, Vikram was fitted with laser altimeter, high resolution camera, lander hazard detection avoidance camera, lander position detection camera, lander horizontal vertical camera, radio altimeters, laser inertial reference and accelerometer package, liquid engine and thrusters. Apart from assisting the landing, Vikram also has some scientific instruments to study moon seismic activity, surface temperature and surface ions at the landing site. These are measured by instruments for lunar seismic activity developed by LEOS, Chandra Surface Thermophysical Experiment developed by SPL, VSSC and PRL, and Rambha LP designed by SPL VSSC. Pragyan was a six-wheeled solar-powered rover with various cameras to provide a three-dimensional terrain view of the lunar surface. These cameras help in the motion of planning of the rover to avoid pointy edges and the risky zones for the rover. Pragyan was attached on lander. Pragyan was fitted with laser-induced breakdown spectroscope and alpha particle-induced X-ray spectroscope used to study the chemical composition of the lunar surface at the landing site. LIBS was developed by Laboratory for Electro-Optic System (LEOS), Bangalore at a unit of ISRO, and APXS was developed by the Physical Research Laboratory, Ahmedabad. Apart from scientific instruments, out of six wheels, the rear two wheels have emblems of India and ISRO, which marks on the lunar soil as the rover move. Chandrayaan 2 has three different modules which have different lifetimes. Rover Pragyan and lander Vikram were expected to have a lifetime of 14 days after landing on the moon. The orbiter was expected to be functional for approximately 7.5 years. All three modules of Chandrayaan 2 have their own different role in helping humankind reach one step closer to the moon. On 22nd July 2019, Chandrayaan 2 was launched by GSLV Mk3 and reached Moon's orbiter on 20th August 2019.
Liftoff will start in T minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
In the last video, we saw an animation on the journey of the Chandrayaan 2 mission. After 4 days of deorbiting during the first phase of landing from 30 km to 7.4 km, Vikram's onboard computer decreased its descent speed as planned mission profile. In the second phase, due to some software glitch, Vikram began to deviate from its landing trajectory and lost contact with ISRO at around 2 km from the lunar surface. Chandrayaan 2 orbiter is currently around the lunar orbit and providing excellent science data resulting in the several firsts. For example, the OHRC onboard Chandrayaan 2 provides the highest ever resolution images of moon. ISRO plans to launch the Chandrayaan 3 mission in the latter part of 2022. Thank you.